I wanted to talk you through the idea of, well, the practice of analyzing negative externalities in markets via graphical analysis. We're going to do a TAP that'll have us do graphical and also algebraic analysis of this issue, but let's talk it through now. And I've got a gasoline market example, and of course auto pollution is a very important contributor to local pollution. Ozone is a big contributor to smog. There's all sorts of other gases that come out of automobiles. Regional pollutants, there's plenty of regional pollutants. These are pollutants that affect maybe a multi-state area. And then of course carbon monoxide, carbon dioxide coming out of cars powered by fossil fuels, whether they be refined oil, that is gasoline, or natural gas, propane. Autos are a huge contributor to greenhouse gases. Let's have a look at that market. Up to now, we've studied markets by means of the demand and the supply curve, and I've talked to you about how the supply curve is derived from the marginal cost function of firms in the industry. Well, we spent a long time developing that idea. We're now going to call the supply curve, instead of just calling it the industry marginal cost curve, we're going to call it the marginal private cost curve. And there's going to be an important distinction between marginal private costs and marginal social costs, and we'll talk about that in just a moment. On the demand side, I've talked to you about how the demand curve can be thought of as the marginal value function for the market. Well, now we're going to call that the marginal private value. That's the demand curve is derived from the private valuation of participants in the market. But there's on either the demand or the supply side, when we're talking about externalities, there's either going to be important benefits or costs that fall on people outside the market. Let's focus on negative externalities. These are costs that fall on people outside the market. And to do that, I'm just going to suppose that the external cost is zero. So marginal external cost is zero. That is going to result in the fact that the marginal private value function is the same as the marginal social value function. So there's no positive externality. Now, I'm going to, and indeed for gasoline, it's well documented that there's plenty of costs associated with both producing and consuming gasoline that fall on people outside the market. Producing gasoline, of course, crude oil production can be messy. The oil can spill out of those wells and contaminate surrounding land. Oil tankers transporting that crude oil can rupture and spill. Refining gasoline can produce some nasty gases, of course. But then, of course, when you use the gasoline, burn it in your car to move your own personal vehicle around, you are producing quite a bit of pollution that affects other people. The other externalities are actually congestion costs. When you make a decision to get in your car and drive to, say, downtown Portland, you're thinking about your time and your getting to Portland, but the fact is your presence on the road contributes to the traffic problems that might exist. So if you're on the road at a rush hour time, at a peak time, you're actually contributing to the fact that traffic is moving more slowly, and so there's a congestion cost that falls on other drivers. And then I guess another external cost, boy, the list is pretty long in gasoline. Another external cost that isn't paid the costs are not attached to the price of the gasoline at all. The United States spends tremendous resources on military excursions in the Middle East, and whether it's propping up Israel and Egypt monetarily or invading Iraq, you know, twice now in the last couple decades. It's not that there weren't reasonable humanitarian reasons for doing what we did, or geopolitical reasons, but the fact is we intervene in that region in large measure because there's so much oil that comes from that region. Anyway, there's actually quite a literature in economics on what is the size of the external costs associated with burning a gallon of gasoline, and estimates are somewhat all over the map, but the most credible estimates suggest that the costs of burning, the costs associated with a gallon of gasoline that fall on people outside the gasoline market are in the range of $5 to $8 per gallon. Those are unpriced costs associated with using gasoline. Anyway, there's a lot of them. How much they are isn't really important at this level, but just realize that there are these external costs. Well, when there's external costs, the marginal social cost function that includes both private and external costs that marginal social cost is higher than the marginal private cost. And indeed, as this equation suggests, the vertical distance, I'm just going to draw it right here above the market equilibrium quantity, this vertical distance between the marginal private cost at Q naught, that's read off of the marginal private cost curve, and the marginal social cost at Q naught, this is the marginal external cost. And I've drawn a case where the marginal external cost is just constant, or I tried to draw that case. Marginal social cost, marginal private costs are just parallel. That isn't necessarily the case, but it's just the easiest one to graph. Well, one more thing we're going to need to think about. We talked a lot about how efficiency in a market occurred where marginal values in the market were equal to marginal costs in the market. It turns out our efficiency condition, correctly put, is the following. Economic efficiency. Economic efficiency occurs at the level of output where marginal social costs are just equal to marginal social values. And realize that when there are important negative externalities, the market equilibrium outcome Q naught is not the economically efficient outcome. Notice that from the point of view of society, another unit of gasoline should be produced as long as the benefits of that unit of gasoline are greater than the costs of that unit of gasoline. So, all these gallons that I'm indicating via this red arrow are valued higher than their social costs of producing them. But that the economically efficient outcome is where marginal social costs are equal to marginal social values. That's right here. I'm going to go ahead and draw that. And I'm going to call that Q star. That's the right level of gasoline. That's the economically efficient level of gasoline. And notice that every gallon of gasoline produced and consumed, every gallon past Q star, costs society more than it benefits anybody in society. And if we count up the excess of costs over benefits for all this extra production of gasoline that occurs in the market outcome that's inefficient, if we count all those extra costs over and above benefits, if we count all those up, we get the dead weight loss associated with the market outcome relative to the socially best outcome. So notice what's happened here in the presence of negative externalities. Our conclusion that the market level of output, even if gasoline were sold in a perfectly competitive market, our conclusion that was efficient is out the window. That is just wrong. So here is an area where the government could improve outcomes with a socially beneficial set of policies. That doesn't mean the government will, but this is an arena where government policy could improve on market outcomes.
Made with Doodlecast Pro.